In question number 11, a body of super dense material with mass twice the mass of Earth but size very small compared to the size of the Earth is released from rest from height h, where h is very less than r, where r is the radius of the Earth. Velocity of approach just before it reaches Earth's surface will be. So suppose this is the Earth and this super dense material of mass 2m is kept here, and m is the mass of Earth and h is the separation between them, and this h is very less as compared to the radius of Earth. So if I take the gravitational potential energy to be 0 reference frame at this point, then I can say that half into reduced mass of system mu into v relative square is equal to minus of delta u, because the motion of the super dense material is only under conservative gravitational forces. So if I write the reduced mass of the system, then I can write half into 2m into m divided by 3m into v relative square at the instant of approach is equal to 2m into gh. So if I solve this, I get the value of Vr, that is the velocity of approach just before it reaches the Earth's surface. So that comes out to be under root 6gh. So option 3 is the correct answer. Let's move to question number 12. In question number 12, a large cylindrical tank has a small hole of area 10 cm square in the bottom of tank. At time t equal to 0, a tap starts to supply water into the tank at a constant rate of 10 raised to the power minus 2 meter cube per second. What is the maximum level of water in the tank? So at the instant of maximum level in the water in the tank, the inward rate of flow of water is equal to the outward rate of flow. The inward volume flow rate of water is equal to the exit volume flow rate. So at that moment I can write Q is equal to A into the velocity of efflux at that moment is under root 2gh. So from here I get the maximum value of h. So it comes out to be q square divided by 2g into a square. So if I substitute the data, the value of q is 10 raised to the power minus 2. So its square is 10 raised to the power minus 4 divided by 2 into g. The value of g I am taking 10 into a. So cross sectional area is 10 centimeter square. So it can be written as 10 raised to the power minus 3. So its square 10 raised to the power minus 6. So on solving, it comes out to be 5 meter. So option 3 is the correct answer. Let's move to question number 13. In question number 13, two particles having de Broglie wavelength lambda 1 and lambda 2 combine to form a third particle having de Broglie wavelength lambda. If they were moving in opposite direction and lambda 1 is greater than lambda 2, then value of lambda is. So from the principle of conservation of linear momentum, we can say that the momentum of the third particle can be written as h by lambda, and that is equal to h by lambda 2 minus h by lambda 1. So if I solve this, the value of lambda comes out to be lambda 1 lambda 2 divided by lambda 1 minus lambda 2. So option 2 is the correct answer. Let's move to question number 14. In question number 14, 1 mole of an ideal gas whose adiabatic constant is 5 by 3 undergoes the process P is equal to P naught plus alpha by V square, where P naught and alpha are positive constants. Minimum possible internal energy of gas is. So from ideal gas equation, we can say that PV is equal to nRT. Number of mole is 1. So I can write 1 into RT is equal to P into V. So the value of P is P naught plus alpha by V square into V. So it can be further written as P naught into V plus alpha by V. So this is the value of RT. So if I differentiate this equation with respect to volume, then I can say that R into dt by dV is equal to P naught minus alpha by V square. So the minimum possible internal energy of gas is possible when the temperature is minimum. So I am checking at what value of V the temperature is minimum. So if I substitute the value of dt by dV is equal to 0, then from here the value of V comes out to be alpha by P naught under root. From here, if I calculate the minimum value of the temperature from this equation, then the value of T minimum comes out to be 2 by r into under root alpha into P naught. So U minimum can be written as NCV into T. So N is 1, gas is monoatomic, so 3R by 2 is CV, and the minimum temperature is 2 by R into under root of alpha into P naught. So if I solve this, it comes out to be 3 times under root of alpha into P naught. So option 2 is the correct answer. Let's move to question number 15. In question number 15, two particles execute SHM with same angular frequency but different amplitudes A and root 3a along same line with same mean position. If they cross each other in opposite direction at a distance root 3 by 2a from mean position, then phase difference between two SHMs is. So in order to understand this problem, let I draw two circles of radii a and root 3a. So this is my first circle, its radius is a, and this is my second circle, its radius is root 3a. So now this is the mean position, and I am taking SHM motion on the vertical y-axis. So at some instant the first particle is at this position and it is moving in this direction, then its projection on the y-axis is at this point, and this separation is given root 3a by 2. So at this moment this is a. So if I find out this angle phi 1, then sin phi 1 is equal to perpendicular, that is root 3a by 2 divided by a. So from here the value of phi 1 comes out to be 60 degree or pi by 3. Now for the second particle is here and this is moving in this direction, so its projection on the y-axis is here and the projection is moving in this direction. They are crossing each other. So at this moment, if I find out what is this angle theta 2, then this angle theta 2 is same as this angle theta 2. Sin theta 2 is equal to perpendicular, that is root 3a by 2 divided by, now its radius is root 3a. So from here the value of theta 2 comes out to be 30 degree or pi by 6. So if this is 30 degree, then phase angle from here phi 2 can be written as 5 pi by 6. So phase difference phi is equal to phi 2 minus phi 1. So 5 pi by 6 minus pi by 3. So if I solve this, it comes out to be pi by 2. So option 3 is the correct answer. Let's move to question number 16.